problem is called rocket launch. Okay, boys and girls, today I know a lot of you have been having a problem with this online assignment. It's a toughie, but I know you can do it. We're on the Earth, first of all. That's always good to know. Here's our little rocket ship, ready for takeoff. Actually, I guess in your problem, you've got the rocket initially having a speed. It's not just at rest. So we're given that. Ultimately, what we're trying to do is we're trying to find out how high your rocket goes and how long it takes to finally come back down and hit the ground. So you're launching a rocket with a certain speed that's given, and while the rocket, for a certain distance through the air, which is given, you're maintaining a constant acceleration rate. Now you're overcoming gravity. That means don't worry about gravity. Sure, we're right near the Earth, so gravity's a factor. That just means your engine has to work harder to overcome it. But ultimately, your rocket is maintaining this acceleration. Now, how high will it go? I don't know. Oh, we could do some physics. If we know we're going at a constant acceleration from some initial velocity to some certain height, we could figure out how long it would take to do that. Let's save that. Let's call that, here we go. Let's call that the time for this part of our problem to occur. Now, the next part of the problem is the engines are cut off. Now, when the engines are cut off, the only thing that this rocket ship is experiencing is gravity. Gravity wants to make the rocket ship fall down and go boom. It's already going some speed though, not this speed. Remember, it accelerated from this speed all the way to, I don't know, let's find out what speed it has when it reaches this point at this height above the ground, and we cut off the engine. That will now be the initial speed, as if I got on a big high ladder and I climbed up here and I held the rocket ship and I threw it up with this speed. How high will it get now? Well, it'll get as high as it gets, and it'll keep slowing down. It'll get as high as it gets to where it stops moving. In other words, where its velocity up here, we'll call that the final velocity, is 0. Initial velocity from the previous problem's final velocity 0. How high will it get? Well, we could figure that out. We know the acceleration in the problem now is g. Hold that thought now. We now know how high the rocket ship gets. It gets this height plus this height high. Now, the problem asks you to find the total time the rocket ship's in the air. The time it takes to get this high while it's accelerating, then the additional time it takes to put, and come to rest. And then it's as if I climbed up on a really high ladder and I simply dropped the rocket from rest. It falls down, accelerating the entire time and over this distance, the total height, and it hits the ground. How much later? I don't know. We'll find out. We have enough information. But the total time the rocket ship is in the air is the sum of these 3 times. Now, we could also calculate how much time it takes, in addition to how far it will go in the second part of the problem. But then, while it's falling from rest, because of gravity, there's a 3rd time factor. This will be how high the rocket goes. The sum of the 3 times, will be how long it takes the rocket to get there.